How y'all doing today? I hope you had a good Easter break. So we're going to go ahead and go into page 274 to 281. We're going to talk about the benefits of a machine today. So let's go ahead and get into our ISM book. Right now I'm on page 137. So remember your ISM book. What I've done is I've drew a line and excuse me, sorry. I drew a line and I put today's date and what I'm doing today. So, like we said, we're talking about machines here, or devices that make tasks easier by changing the magnitude of the direction of the applied force. It gave us an example of a bottle top opener and how we have mechanical advantage of that, which would be Fe, the effort force, against the resistant force. And it also gave us a resistor resistance, which is MA, which is mechanical advantage, which is FR over FE. Talked about ideal mechanical advantage, energy, which is IMA, that's ideal mechanical energy, equals displacement effort over displacement force. So that is a formula. So I'm going to go ahead, and these are variables, so I'm going to make my variables in this orange so they'll stand out for me so I can see it. Okay, efficiency of a machine is the definition as the ratio of output work to the input work. So there is another equation for efficiency, equals work output over work input times 100. And so if 1 is equal to this number, then it is 100%. Then it gave us also this other one about efficiency, mechanical advantage over ideal mechanical advantage times 100. So that is also another one. Also on here, they gave us some information about compound machines. So when we're talking about a combination of one or more, there's 6 different types. That's these here. We have a lever, a wheel, an axle, inclined plane, and a wedge, and a screw. Those are ours. And then it had a picture of these IMAs and how to do it. This right here is very, very important. So you'll go back to these. I drew them from the book because the textbook actually told us the length times the width, and I have these formulas. Personally, myself, I wish I had drawn it in a longer page so I could actually look at it better, but I did not. But that would be something that you would want to do. And then over here, we have mechanical advantage of a bicycle. So what they did with the bicycle is they were giving us some mechanical advantage total, would be the pedal and the rear gear. As you remember, there are 2 machines here that are working on a bicycle, your pedal and the wheel. So to be able to do that, you would have to do the force on the gear on the chain divided by the force on the rider on the pedal times the force of the wheel on the road divided by the force on the chain on the gear. Force on the wheel on the road divided by the the force on the rider on the pedal. So these are some things that we would have to do. So for the next thing I want to do is I want to go to the example problem that we have in the textbook. That was page 279. On page 279, they have a question, and it shows us a question about a wheel. So here what we have is we have a wheel. We have some of the forces that we have labeled. Here are our variables, and then we have to go and solve for IMA, MA, force, and distance. So to be able to do that, what we would have to do for the first one, we're solving for IMA. To be able to do that one, we have to take our RE and divide it by our R. That gives us our number of 0.12. As you see, there's no units of measurements here, are they? The next one is we're looking for MA. So we're trying to find the energy, right, of MA over IMA. So we're going to go and we're going to take our 95, which is 95%, over, and then the bottom part is the IMA, which is 100%, times the number, which is the IMA, which is the number that we got here, right? To get our number. So, if we were doing it in a calculator, we would have an open bracket, and then alpha y equal, and then we would have 95 divided by 100 over a close bracket, and then we're going to times that by our 0.112, enter, and we get, and let me change the mode to normal, second answer, we get 0.1064. So I could put the 4 there too, okay? And then C, we're trying to find for the force. So one thing we're going to do is we're going to take the answer that we got, which was our MA, and times our FE, which is in the front, and that would give us 16.4. And then we have to solve for distance. And to be able to do that, we're going to take our 0.112, times it by our 14 to get 1.57 centimeters. This has units. This has units. So let's look. So for questions that we have on page 280, I went ahead and did 2 problems. So if you're watching the video, you only have to do 2. So the first one says, if a gear ratio of the bicycle in example problem 4 is doubled while the force exerted on the chain and the distance of the wheel rim moves remains the same, what quantities change and how much? So the only thing we're doing here is we're taking this information here and we're just doubling it. So we're going to take our 8 over 35 to get ours 0.225. Once we get that, then what we're going to do is we're going to go and we're going to take this number and put it in this equation here, right, to get this number. Then we're going to take this one to get our force, which is 32.2 newtons. And then the last thing we're going to do is we're going to plug it into the last part of what we did here. So we're basically just doing the same problem again, except with numbers that are doubled. Okay? So 26 says, a sledgehammer is used to drive a wedge into a log to split it. When the wedge is driven 0.20 meters into the log is separated at the distance of 5.0 centimeters. The force of 1.7 times 10 to the 4th newtons is given to split the log. The sledgehammer exerts a force of 1.1 times 10 to the 4th. What is the IMA of the wedge? So we're going to take our DE, which in our equation, our DE is going to be equal to 0.20 meters, okay? And then we're going to take our DR, which is going to be our 5.0 centimeters, but we're going to change that 5.0 centimeters to meters, so we're just having to move the decimal over, okay? And then we're going to get our number for that. The next one asks for MA of the wedge. For that one there, we're going to go up here. We have 2 forces. We have the resistance force and the energy force. So the first one says that the force is 1.7 times 10 to the 4th newtons. And that's going to be our force resistance. And it says is needed to split the wood. That's the force that's needed. Okay. The sledgehammer exerts. So for our sledgehammer, actually exerts 1.1 times 10 to the 4th newtons. So we're going to, and that's going to be our second number. So we're going to put it in our calculator. Alpha y, enter. We're going to do 1.7 times 10, caret 4 over and down. And 1.1 times 10, caret 4 over, enter. And we get 1.5. And then the last thing we're going to do is it asks us to calculate the efficiency of the wedge on the machine. So we're going to take this number divided by that number times 100. So that would be alpha y, enter, and it would be 1.5 over 4.0 over times 100. And that gives us 37.5, which we would round up to 38 to make an even number. All right, so the last thing we're going to do is we're going to talk about the next section, just a couple of things. So first things first is we have a multi-gear bicycle. We have an upper gear and a lower gear. You can either choose both gears or you can actually choose one. Remember that the rear gear actually has 5 sides and the lower gear only has 1. When you have the lower gears, the rate in which they are pedaling, you increase, but you have less force that you have to use. When you have a higher gear, more force, but less rotation. Okay? And then the last part was the connection to biology. And what it did there, it was talking about a walking machine of your body. And it was talking about how when you look at this, you are a machine. You have a rigid bone, bare bone, which is this here. Which is this right here. You have the source of the force, which is the muscle contraction. You have the fulcrum or the pivot, which is number 3 right here. And then the resistance, which is the weight of the body. And that there will conclude this section. So the only thing you have left to do is you will have a review questions tomorrow, and then you'll have another test. I hope you have a good day.